Kobi. Good to have you back. It's been a little while. Yeah, it's been an interesting time. I saw a lot of announcements coming out of Weebit recently. Maybe let's kick off with that. You announced a few test results recently. What did you test exactly, and what is the significance of the results?
Yeah, so we've been focusing on productization right now. So we're working on getting everything ready to go to market. And the key challenge, of course, is to make your product competitive in the market space. The big thing right now is that we've achieved, on the more important parameters, on the endurance, retention, and voltages, we've achieved the levels that are competitive in the marketplace. So now, in terms of the technical parameters, we're ready. Obviously, there's a lot more work to be done. And there's all of the work to move to a production fab, 300 millimeters, things that we talked about in the past. Mm-hmm. But it's definitely a very major step for us.
Right. So to get to production readiness, so going to 300 millimeters is obviously the one of the key things. So we've got one right here. Maybe just
this is actually the 200 millimeter.
Oh, sorry. Yeah, this is the smaller. Yeah. So of course, obviously, 300 quite a bit bigger. But so moving into that diameter size. So can you work from that at 40 nanometers, or do you still need to go to 28 nanometers and to go into volume production through a licensee maybe?
So I think as we discussed in a previous meeting, our memory dot, actually, nanometers are used to measure transistors, not resistors. So it's kind of a little confusing when we talk about it. The 40 nanometers is really the wafer that we are using to test our ReRAM, but in reality, our ReRAM cell itself can fit in much smaller dimensions. So we're always optimizing and reducing the size and so on. But right now, the key element is really to move to the 300 millimeter, which I guess a side effect of it is you normally move to the 28 nanometer substrate already and get that ready for production.
Right. But the bottom line is, given that you've basically validated the technology to a large extent, moving to 300 mil plus 28 nanometers should be relatively straightforward. Is that a fair assumption?
We definitely, now it's more a matter of just hard work. The risk level has gone down dramatically. Right. Now that we have a megabit array, now that we have the retention, endurance, voltages, now the risk level is much, much lower. Right. It's more just doing the work. Right.
Is that lower risk level also translated into your conversations with industry participants, potential licensees, collaborators? Can you talk a little bit about that?
We've been talking to a lot of people. Now that we've reached these technical levels, it's opened the door even more. So there are some serious discussions going on. When you're talking to customers, it's always a matter of their product life cycle and hitting it at the right spot and all of the considerations that they have and they want to check more and so on. But there's definitely serious discussions going on.
All right. Just on some of the announcements the collaborations you announced, Technion was one of the ones that stood out. With all due respect to the other ones, but Technion is, I think, in that group of announcements you made, probably one of the most sort of leading institutes globally. So I was just wondering, you talk about real processing in memory. I know it's a very complicated topic, but I think from a future application area, it's so interesting that we should touch on it today as well. Maybe at a very high level, but maybe can you talk through what it means, what it does, and where ReRAM comes in?
Okay. Yeah, it is a very exciting domain. Until recently, or until now even, when you look at a computer, you normally have a very strong, smart processor that does all of the logic, and then there's a stupid, memory next to it that's just a storage unit. So the processor reads and writes from the memory, but that's it. The memory doesn't do anything. More recently, people have tried to make the memories smarter. and so they basically add logic into the memory. Now, what they actually do is they put some logic next to the memory, and that's what people are calling processing in memory, where you can, for example, send a picture or an image to the memory and say, do you have something like this anywhere in the memory? And the memory will actually search inside and just give you a yes/no answer instead of just giving you things and you checking in the processor. That speeds up things a lot for AI and so on. What we're talking about here is something really amazing, where the memory cells themselves are used to, you connect them in such a way that they themselves do the logic. So it's not external logic that's just put next to the memory inside the memory module. It's actually using the memory itself to do the logic, and that's what's really amazing here.
Right. How far away is that from hitting the market realistically?
Oh, that's still in research mode. That's something that's going to take probably a few years.
Yeah. Okay. So looking at the application areas for Weebit now, you're just using your ReRAM technology. You've got embedded, which is probably the closest to market, I'd say. Potentially storage class memory. You probably need to tweak the parameters of the technology a little bit to address that segment of the storage market, but that's relatively close as well, I'd say. We're still talking about a few years, but and then you've got real processing in memory. And then also, and this is what we talked about a little while ago, is the potential for hardware-only AI solutions, or basically neuromorphic chips. Yeah. So you've got 4 application areas. Some are further away than others, but does that, from an outsider point of view, potential collaborators or clients, does that make the picture more attractive for them to be working with you guys on maybe 1 or 2 or maybe all 4 of these areas?
Yeah. So, there's 4 domains. Obviously, as a commercial company, the big focus right now is we need to get to revenues. And so my big focus is the embedded market, and that's where the company is focused. We just want to get that to productization. So, but it is very exciting, all of these other domains, and that's where we're collaborating with research institutes so that we're providing them with the hardware, our chips, and they're doing the research. We're participating, we're giving some advice, but they're doing the work, and we can leverage that. Okay. I think that storage class memory is something that, with the progress that Flash has made, with the 3D NAND, they've managed to make it so cheap that right now, it's going to be a difficult competition. I mean, it's obviously something that we're looking at as a next step, but that's going to take us time to get to the point where we're really managing to compete with the price point on the Flash, on the 3D NAND. The neuromorphic is something that's already starting to get to the market. I mean, you already see commercial companies starting to look at it and how to use it. So it's very exciting, and the cooperation with IIT Delhi, with Politecnico di Milano, it's really exciting there. Yeah. And the longer term, really the kind of the furthest out is the processing in memory, the real processing in memory.
Right. Okay. So we should continue to focus on embedded for now.
Yeah. For me, everyone's expecting me to bring revenue, and it's very normally so, and that's what we're going to do.
Yeah, it's good to have that focus, but still keeping the longer term sort of potential in the back of your mind. Yeah. All right. So lastly, then on you've got the EGM today.
Yeah.
I quickly wanted to talk to you about the share consolidation. Maybe if you can talk about your motives for doing that. It's interesting to hear about that because ultimately the value of anyone's shareholdings will remain unchanged, even though you do typically see some fluctuation in share price just post consolidation.
Yeah, I mean it's a technicality, right? Yeah. The share value goes up, the number of share goes down. At the end of the day, it's the same. Yeah. The market cap doesn't change. But we've been getting the comment from many of the institutional investors, the family offices, the people who are thinking more longer term, that, I mean, we have right now 1.6 billion shares. That's a huge number. Yeah. Fully diluted, it's even more like 1.8 or something like that. So it's really, it doesn't make any sense. And then the value of the share is so low that every tick in the trading, it's plus or minus almost 5%, which again causes instability to a certain extent. Yeah. So people wanted to see it become, quotes, more reasonable, and that's why we're doing it. I think this will open the door for more, I would say, established institutionals and funds and so on to come in.
Yeah, all right, excellent. All right, thanks, Kobi, for dropping by and updating us on the latest developments.
Okay, thank you.